Oh, good morning, afternoon, or evening from wherever in the world you're joining us from. Welcome to this Phase 1 Industrial webinar. This is regarding our IX Plan and IX Flight and how to use both software packages successfully to execute successful survey missions. My name is James Wardlaw. I'm the System Sales Manager for EMEA, and I would just like to take you through the various features of IX Plan and IX Flight. So first, we'll just start on a brief introduction of Phase 1. Many of you will already know the information for this, but for some new customers or visitors to us, this is nice information to know. So Phase 1, we are a world-leading provider of medium format digital imaging systems and solutions. This is for industrial applications ranging from UAV imaging, from mapping to inspection, through to airborne manned imaging solutions, through to more recently machine vision and homeland security. So Phase 1, we are a trusted brand with more than 100,000 satisfied customers. We are the market leader in medium format imaging. We have a worldwide distribution infrastructure, and with this worldwide infrastructure, we have a 24/7 global customer support. And this also bodes towards our customer-centric and innovative team with more than 25 nationalities supported both internally with Phase 1 and through our distribution network. So the company infrastructure, so we are headquarters in Copenhagen. So in Copenhagen we have primary research and development. We also have R&D in Israel and also in Japan. For our sales, we're also directly involved with North America through our Sales and Support Center in Denver, Colorado, for our Sales and Support Center in Cologne in Germany, and also sales and support through Hong Kong. On top of this, we are already also global coverage, including a distribution network of service sales and partners of more than 50, which covers all regions across the globe. So first off, we'll take a look at IX Plan. So IX Plan is the planning part of our software. So through here, we can make our flight plannings for various aerial survey missions, executions, for example, standard vertical photography, oblique photography. So we'll just start with a quick overview. So IX Plan is a simple user interface. It allows for quick mission planning. This is done through various wizarding tools. Within the software, there's powerful vector file manipulation, so you can import, export various vector files. You can adjust those vector files. You can buffer those vector files easily inside the software, so it cuts down on the requirement of third-party software. There's also the ability to import various raster files. These can be used for mission planning and also can be used for backgrounds, and this also includes download straight from Google Earth. On top of this, there are also powerful quality control tools. These tools can be used for ensuring that planning is done to specification, ensuring that crew safety on a mission is not compromised. So these tools are very powerful for both accuracy assessment and from a safety point of view. And at the end, you have the ability to export your flight plan to a wide range of formats, which includes XLS sheets, text files, picture-based documents. So a lot of export options which can be used for planning, budget analysis, and also crew documentation. So if we look at the initial phase of starting a project, so inside the camera sensor definitions, all Phase 1 cameras are already included. All of the definitions are included, so there's nothing to change here. You just need to ensure that you select the correct camera and focal length for your particular mission planning. So all cameras, past and present, are included, from the IXA right up to the brand new IXM and IXM-RS cameras. So on top of this, we have a wide variety of supported vector files. So the vector file is generally supplied to you by your customer. This will be the AOI, or area of interest. We can support files including DXF, shape, KML, and also most worldwide supported projections and datums are already included inside the software. but new projections can be added by either providing us with the EPSG code to provide you a new projection file, or you can manually define that projection inside the software as long as you know the required transformations. You can also import a wide variety of supported raster files, including TFW and JPGW. You can use these to directly plan from if you know that there's a certain area, for example, in a M25 corridor for the London area, for example. If you know that you have the required topographical charts, and you can already make a planning based directly from the raster file. So once the importation of data is completed, you're left with the mapping window. So the mapping window itself is very versatile. You have the ability to turn on and off any of the visible components. If you want to hide the flight lines because you just want to take care of the image centers, then you can turn those off. You can turn off the overlaps, the coverage. So anything that you want to switch on and off, you can do it at leisure. You can also add extra vector files, raster files on the go. You can also manipulate any of the vector files that you import here, so you can buffer them. You can change the shading, change the outline colors, change the borders, change the labels, give them a label. So you can really change the loaded data inside the screen here. There are also a multiple of visible error notifications. So in the top right-hand corner of the screen, you can see highlighted by green, it's currently indicating no duplicate line IDs and no overlap problems. So as you're going through the planning, you'll see if there are any problems on the go, so you can quickly make the amendments as you go along. So once the flight plan is imported, we want to then consider the terrain for the area so that you can make an accurate flight planning. So all common DEM formats are supported. You have a direct download from SRTM. The following slide will show the wizard for downloading the SRTM. But on top of this, you can also import from user-created GeoTIFF, USGSDM, XYZ text file, and once you've imported your data, you can then export that out to what is known as the iXplan quadtree format. And what's nice about the iXplan quadtree format, if in future you need to replan the area and the client has a requirement for a different specification, so you need to start the flight plan from scratch, instead of having to go through the importation again to import directly from SRTM, you can just directly import your previously saved quadtree. So this is a nice feature to be able to save a lot of time there. So with the SRTM download, so it's an easy to use data wizard. So as you can see, we have SRTM has almost 100% global coverage. This is accurate DEM data. It's the latest SRTM3, which is accurate to a resolution of 3 arcseconds or 90-meter resolution. So once you have the DTM imported, we can look at the line creation. So inside iXplan, there's a multitude of line creation and editing tools. With these line creation editing tools, you can change, of course, GSDs, forward overlaps, side overlaps, maximums and minimums. You can set fixed flight altitudes, fixed flight bases. You can have fixed flight lengths if it's a customer requirement. And you can also select a predetermined azimuth direction if that's also a requirement. Another nice feature with this software is that it allows for multiple AOI planning. So you can create multiple AOIs with varying parameters in one flight plan. So what this means is you can import several different AOIs, customer AOIs from one region, and they might have all separate specifications required. Inside the iXplan, you can actually plan for these separately in the single flight plan, which means you don't have to set up the project several times, making several new flight plans. As already mentioned, you have the ability to create an AOI buffer, so you can create this buffer which you can either use just to give yourself a little bit of an extra margin to ensure full coverage. You can use this buffer to use it for oblique flight planning, so you can make sure that you have your oblique angle right out to the edge of the AOI. And you also have the ability to autofill selected AOIs with the currently selected and highlighted parameters. Run numbering is simple and straightforward. There are several ways of doing this. You can either manually number the runs, or you can do this semi-automatically or automatically, and it will give each run a unique identification. There's also the ability to import your ground controls. So on the screen there, they are highlighted as the blue triangles. So the ability to import these GCPs already allow you to optimize your flight paths and your runs so that you can optimize the usage of your ground control to their optimal capacity. So on top of the flight planning, as already mentioned in the brief, we have various quality control tools. These help ensure that flight planning is completed to specification. So with these quality control tools, you have the ability to check and ensure your ground sample distance, side overlaps, forward overlaps. You can check your AGL heights and maximum possible ground speed, which is based on the DEM and camera cycle time. You also have the ability to check the image sequencing given aircraft's operational speed and camera cycle time to ensure that you're not going to exceed that camera's maximum cycle time. As you can see on the example, there are some waypoints highlighted under red, so these would indicate where the maximum capture time of the camera is being exceeded. So it's a quick visual check to be able to see that everything that you're creating is to within spec and is going to make a successful survey mission. Once you've created these QC reports, they're all exportable, so you can use them as part of your quality control process for internal reporting or external reporting to the client. On top of the QC tools that can be used for quality control, there are also various tools that can be used to ensure the safety of the crew. So this example on the screen here is basically showing the proximity of the aircraft's flight path to the terrain. So you can see there in the middle of the flight plan there's an area highlighted yellow, and looking at the wizard, that's showing that the aircraft is going to come within 500 to 1,000 meters. So in that instance, you would then be able to refine those values, so you could actually see exactly what is the actual altitude that you're going to be over that terrain, so you can ensure that there's no conflict for the aircrew, and also that no rules or regulations are going to be exceeded. What else is nice about this tool is you can actually tell the software the speed of the aircraft, the anticipated time to complete the standard turn, and then it will also take into account the aircraft's turning circles to ensure that the positioning turn for the reciprocal heading isn't also going to be compromised by terrain. So once the flight plan is completed and you're happy it's to specification, as mentioned, you can already import a variety of raster backgrounds. So through this, you can import geo-referenced ATC charts. These you can use to submit to ATC, so ATC can clearly see what altitudes you're going to be flying the prescribed runs, which airspace is it going to impinge on. So it's a nice tool to be able to export reports for both client reporting, ATC submission, as well as being able to import your own geo-referenced charts. You can also download from Google Earth and Google Street View. There's also the ability to export a variety of default XLS and text reports, and on top of this you can also create your own user-defined XLS and text reports. These are nice because you can use these for cost analysis, budgeting, so you can see how long is each individual track. You can tell the XLS how long is it going to take on a positioning turn, what is the speed of the aircraft, and already through this report it will generate an automatic assessment on how it anticipates the time on target will be. So there are a lot of options here that you can use for cost assessment and budgeting. So that's finishing the IX plan. So now we'll have a look at the IX flight. So IX flight is a brief overview. So IX flight is designed by pilots and survey operators for use by pilots and survey operators. So what we mean by this is we really want to make a product that is useful for aerial survey from both a pilot perspective and an operator's perspective. We're going to achieve this as well by having this is currently a living product. So we're encouraging our users of IX Flight to constantly give us feedback, tell us what they want to have included, what they want to have adjusted. So what we're trying to make here is we don't want a stagnant flight management system. We want something that's going to develop and evolve into something that will be at the forefront of aerial survey. So the actual interface itself, it's simple, streamlined interface. Only the pertinent information that's required for the successful mission is displayed. So we have on there the distance to start of the run, the bearing to start of the run, distance to the end, cross-track errors, altitude errors. There isn't any information on there that isn't required to successfully pick up the track and fly a successful mission. So on top of that, we have many developments already planned for release this year. So this is it will further enhance the user experience in both the flight management and also the post-flight experience. So we start with the sense handler. So sense handler is the master interface between all functions of the system. So it's the interface between the Planix. It sends the Planix data through to the IX flight to give the positional information. It will then read the aircraft's position in reference to the pre-planned photo positions, and it will send that trigger to the camera. So everything is being controlled by our sense handler. It's easy to connect your devices, and it's easy to monitor your devices for a connection and also for their ready status. So as mentioned, to monitor the connection and ready status, you can see now on the left, we have everything is highlighted as green. This shows that everything is connected and is ready for operation. The only thing that isn't highlighted green is the SOMAG, which is highlighted as yellow, which is normal. This will show us that the aircraft hasn't entered the flight corridor yet, and the mount is still in frozen mode. Through the sense handler, we have some advanced testing and diagnostic tools, so you can extend the window. Through this, you can trigger the camera for a test shot. You can force the mount into stabilization mode. You can manually view the data stream from the GPS device. So this can be used to check for any errors. If there's an issue anywhere, then you can do all your diagnostic checking easily through the sense handler. So with project selection, this is the opening interface for IX Flight. So through here, you can easily add projects, remove projects from the list. So it's quite simple, straightforward to only include the projects that are currently active. So it's quite easy as long as the project is with the operator and is available on the IX controller. Then this is easy and quick to load up in the software. So all aspects of the flight are controlled from the operator display. There is a simplified screen which is basically mirrored to the pilot display, but he only has the ability to zoom the interface in, zoom the interface out, and pan the screen around. So run selection, all of the other options are controlled purely by the operator. It's a simplified screen, as already mentioned, showing only the information required for a successful mission. We have the distance, time and bearing to start of the line displayed. We have a simple altitude function which is highlighted on the right of the display, so we can see quickly from there that 1,831 feet highlighted by purple is the desired altitude. The 0 feet highlighted by red is the current altitude or GPS altitude, and the plus 1,831 feet is quite clearly indicating to us that we have to climb 1,831 to meet our planned altitude. For the cross-track deviation, we have a traffic light pattern symbol. So the aircraft is highlighted by the middle green rectangle. So it's quite clearly to see from the screen that we have to come to the left. And there's also a numeric indicator telling us that we have to come left by 1,042 meters. So it's quick and easy to see where you have to go to position for the next flight line. So for positioning onto the flight lines, so our turn guides are calculated based on performing a coordinated standard rate turn of 360 degrees in 2 minutes. So this can be used by the pilot by referencing the turn coordinator. So as you can see on the indicator on the middle of the screen, that would be the indication that the pilot would be looking for to perform a standard rate turn. So as long as the purple turning circle guides are on the edge of the intended track to pick up, then it's quick and easy for the pilot to intercept the next heading. And we've actually now got a short video showing this in action. So as you can see, the pilot is performing a standard rate 110. He has the purple turning circle always positioned on the blue extended centre line for the track, so it makes it really easy for the pilot to be able to pick up the next waypoint. So the online heading or the track up display once we're in the corridor again clearly shows the corrections the pilot must make to hold the line. So we can see on the altitude on the right hand side, the desired altitude is 2,000 feet. The pilot currently has to make a climb of 131 feet to maintain his altitude. We can see from the top as well, from the traffic light indication for the cross-track deviation. The pilot is indicated by the large green rectangle in the center. The line is indicated by the narrower green rectangle just off to the left. So looking at the actual plane reference to the line and looking at the numeric value, it's clear to see the pilot needs to come left just 7 meters to maintain that track. You can also see reference just above the airspeed of 120 knots, and where it says to end, we have the 30 meters reference. That is the tolerances for the corridor. These tolerances are all user definable, so the user can define his own tolerances. What will happen if the pilot exits the corridor outside of these tolerances is the camera will stop triggering. So it quickly highlights if for example, the pilot has left the corridor and the tolerances for side overlap, for example, have been exceeded. So already when the imagery is delivered back to photogrammetry, they can quite quickly and clearly see that those set frames were flown outside of specification. So for selecting runs, it's quite simple, straightforward. Just press the next desired run that you want to fly and then activate it with the green tick. We also have the ability to auto sequence the lines, so you can actually set the sequence of the lines that you want to fly in, and the software, once you complete the previous line, will automatically switch to the next following line. What is nice for this is if you're flying a complex flight area and you have a lot of flight runs or flight paths in different directions, it's good always to have a discussion pre-flight on the ground to discuss the most economical way of targeting those runs, and then on the ground it's easy for the operator to already dial those runs up into the sequence, so that in the air the flight pattern is already being selected automatically for both the pilot and the operator. So as already mentioned, the software is fully user definable, so you can change anything with regards to the tolerances, the colors of the backgrounds, the aircraft, the indicators. This can all be changed. User defined units for navigation, all units or standard units of aviation are included inside the software. So we have meters, feet and nautical miles for distances, kilometers per hour and knots for speed, meters, feet, altitude, and meters, feet and nautical miles for cross distance. So it's very easy for you to customize this to user preference. So that brings us to the end of the presentation on IXPlan and IXFlight. So for more information or to book a demonstration, you can visit us on our website, which is illustrated on the screen. Alternatively, you can contact me directly. As mentioned, I'm James Wardlaw, System Sales Manager for EMEA. My email is listed there, jwa@phase1.com. My mobile number is also listed, but bear in mind I'm UK based, so depending on the time zone, time difference, it's probably best just to drop me an email first. Or alternatively, you can also contact Udi Menaker. Udi is our product manager, so he's taking care of the development of the aerial systems, the IXPlan, IXFlight. So if you have any recommendations for the software, or if you want to talk in more detail with Udi about the software, then his email is listed. And what I'd like to finish off with is just a couple of sample images that we collected with the Phase 1 aerial system last week in Australia. So this image was collected in an area called Aspendale, which is in Victoria. It's just southeast of Melbourne. It was captured with our IXU 1900 RS system. It was at a GST of 3 centimeters, which with the IXU 1900 is about 1900 feet. We were flying in an Air Commander 500, so online at about 130 knots. But what's nice to see is in the area that I've highlighted, zoomed in, you can clearly see the couple walking with their dog. You can see the footprints in the sand. There's a little exploded view there from the 4-band false color infrared. And then the next image was taken actually on the approach back into Essendon Airport. So this is the VRC, or the Victoria Race Club. So this is the host of the Melbourne Cup each year for any horse fans joining us. So this was captured at about 1,130 feet on the approach. So it's about 1.76 centimeter GST. We're doing about 90 knots. And what's interesting to know is interesting to see is when you zoom right in onto the little circle with the VRC logo, you can actually see the ripples and the indentations inside the fabric of the software. So yeah, really nice imagery. If you want to get your hands on any of the sample data, please feel free to drop me an email or contact us through the website, and we can provide you with various samples from this recent flights or from any flights that we've previously done with this system. So once again, many thanks for your attendance, and thank you for listening. And if anyone has any questions, we can take them now.
Hey James, this is Paula. There's one question that's just come in asking, does IX Flight have the ability to display the image footprints?
Yes, it does. So IX Flight, you can configure it to show not only the image footprints, but you can also ask it to show you the stereo models. So everything that is created in IX Plan is basically shapefile based. So anything that is created inside IX Plan or IX Flight can be exported as shapefile.
Okay, that's it. I think there's no more questions, so you've obviously answered everything for everybody. So.
Okay. So thank you very much once again for attending. The webinar will be available shortly for review again on the Phase 1 website. All webinars that we create go on the website, as well as the calendar for upcoming webinars. So keep an eye on the website there for the webinars past, and also the future webinars, just in case there's something else for your interest. Thank you very much.